Hey everybody, hope everybody's doing well. We're going to be working on a practice problem today. We're currently doing time series and forecasting. And this problem is going to deal with estimating seasonal effects using an additive decomposition model, as well as estimating trend once we've accounted for that. So, without further ado, let's get to it. It's chapter 18, question 32. I'll read the question, then I'll go through all the questions and we'll answer them. South Shore Construction builds permanent docks and seawalls along the southern shore of Long Island, New York. Although the firm has been in business only 5 years, revenue has increased from $308,000 in the first year of operation to $1,084,000 in the most recent year. The data, on the Data tab, that's down here, show the quarterly sales revenue in thousands of dollars. Part A is asking us to construct a time series plot. What type of pattern exists in the data? So we'll do that first. Next, we will use the following dummy variables to develop an estimated regression equation to account for any seasonal effects in the data. And then it's going to define dummies for the first 3 quarters. Based only on the seasonal effect, compute estimates of quarterly sales for year 6. Then part C is asking us to develop a period. Let period equal 1 refer to the observation in quarter 1 of year 1, period equal 2 refer to the observation in quarter 2 of year 1, and so on until we get to the last one. Period 20 is the last period, quarter 4 of year 5. Using the dummy variables and the period variable, develop an estimated regression equation to account for seasonal effects and any linear trend. Based upon the seasonal effects and the linear trend, compute an estimate of quarterly sales for year 6. Okay, so we can do that. First things first, let's construct our time series plot. Okay, so this data is right here. Now, in order to construct a time series plot, one thing we can do, I think, is just this. I haven't tried this before. We'll see if this works. Yep. If you just select the data and click Insert, Scatter, and then the zigzaggy thing, it just automatically will give you a time series plot. That's what it looks like. So what does it look like? Well, it does look like we have an upward trend, right? It's going up. It also looks like there are clear seasonal effects, right? So we start low, go up again, then down, then down, then up, and then down, down, up, and then down, up, and then down, up, and then down. So we do appear to have a seasonal effect. Now, what we're going to do is we're going to introduce dummies, and the effect that these dummies have, I talked about this a little bit in 1830, but I'll talk about it again now, is, actually, let me copy this sheet so that we can use one for the data and one for talking about this graph. Okay, so this is the same data, same chart, but I want to draw on this a little bit. Now, if we were just to estimate a trend like so, or estimate even the mean, right? What we would be doing when we estimated the mean would just be drawing one line through like the middle-ish of all these points, something like that. It should be a straight line, so let's try that again. Something like that. That might be the mean. When we introduce just quarterly dummies, what that does is that gives us 4 different means. We're not using a trend at this point. I'm not sure why that got curly. But what we're saying is, well, this is one. These are all belong to the same quarter. So we're going to estimate one line for the mean here, and that's going to be our projection for the future. We have a different quarter, which is, say, the first quarter every time. Maybe that's these ones. And then we'll estimate another mean for those. The second ones, we'll estimate a mean for the second ones. Here, maybe here, 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 and here. And we'll just draw a mean line there. And that's what introducing dummies does. It'll give us, instead of just one mean for the overall, we'll get a mean for quarter 1, a mean for quarter 2, a mean for quarter 3, a mean for quarter 4. But in any case, that's part A, pardon me. Part A is to draw this graph like this, not with all the lines in it, but just the zigzags. And then to say, what does it appear to have? Well, it looks like there's a seasonal effect. So we can, if we want, we can say C data 2 tab. There appears to be a seasonal pattern as well as a trend. And a trend. There we go. Wrap this quick. Control 1. Okay, so part A is done. We have our time series plot, we have a seasonal pattern and a trend. Now we're going to do part B. This is where we're going to introduce dummies that's going to account for seasonal effects. And then based on those seasonal effects, we're going to compute some estimates. So it's asking us to come up with, what do we have? QTR1, QTR2, and QTR3. Now QTR1 is going to be a dummy that equals 1 if it's the first quarter, like here, 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 and here, and it's going to be 0 everywhere else. There are two ways to do this. One is just to do this. One, I'm just typing the numbers. An easier, maybe easier way, a way that includes the logic in the file so that we know what we're doing, is this. If b2 equals 1, then then the value is 1, otherwise it's 0. Now if we copy this and paste it, it's replacing b2, you see, with b7 and b8 and b9, b10. Oh, b10 is 1, so that's going to be 1 over and over and over and over again. So if we copy and paste that all the way down, we're good. Now we can copy and paste this over here, but it causes some problems. First of all, it's changed it to C2, and we want it to still be B2. And second of all, it's setting it equal to 1 instead of 2. So how can we solve this? Well, one way to do that is to make this an absolute column. That $sign means that if I copy and paste this somewhere else, change the number, but don't change the letter. So I can paste this all the way down and it'll have no effect. But now if I copy this over here, it's still B2 instead of C2. That's good. But I don't want this quarter 2 dummy. It should be defined to be 1 if it's the second quarter. So I just have to replace this with 2. And now if I copy this all the way down, you can see that we have those dummies defined properly. Move it over here. We're just going to need to change this to 3. And we can copy this all the way down. Usually when I do this myself, what I will do is I'll just do it for these 3 cases, right? So that one's correct, that one's correct, that one's correct, and then I'll copy these all the way down right away. So I often will make sure that that I have my formulas correct in a top row, and then I'll fill that top row all the way down so that it adjusts correctly. Anyway, that's how we define our dummies. I'll just format these so that they look nice. And I like all my numbers to be centered for no good reason, unless there's a good reason otherwise. Anyway, there we go. So now we have our dummies. What's it asking us to do? It's asking us to develop an estimated regression equation with just these dummies. So let's write that model that it's asking us to estimate. Okay, so we're going to let y equal sales, and then we're going to estimate this model. Y equals beta 0. Again, this is the model. And this is what we're positing. We're saying that sales depends on some intercept plus beta 1 times QTR1. And remember, QTR1 is only 1 if it's the first quarter. So beta 1 is going to be like a quarter 1 bonus or penalty, depending on whether it's positive or negative. Plus beta 2 times QTR2 plus beta 3 times QTR3 plus some random error. Right, that's what that is. Okay. So let's see what do we get when we estimate that model. We're going to use that, by the way. Might as well throw this in here too. We're going to use that to come up with an estimated regression equation, which if you've been following along with the videos, you're pretty familiar with the difference between these now, because oftentimes we take a model, the model is what we think is going on in the population. The estimated regression equation is actually a numerical statement about what is the best fit for our actual data. And in this case, we have y hat, which is our estimated sales or predicted sales, is going to be equal to b0 plus b1 times qtr1 plus b2 times qtr2 plus b3 times qtr3, and we don't have an error anymore. We've eliminated that, or attempted to. Okay, and B0, B1, and B2, these are going to be our estimates of beta 0, beta 1, beta 2, and beta 3. We're asking Excel to choose the B0, B1, B2, B3 that minimizes the sum of squared errors, which is to say, give us the best fit, the ones that fit the data best. That's what we're really doing. I feel like there was something else I was going to say. I don't know. Anyway, let's run this regression now. So we want to go to the Data tab. Click Data Analysis. I'm going to choose Regression. Come on, there we are, Regression. Okay. Now our input, our Y, is going to be revenue, because that's not sales. I said sales. It's revenue. Sorry, my model is not technically correct, but it will work just fine. We included the label, so we want to check that. And then our new worksheet is going to be called rev equals quarterdums. That way I know from the tab what the dependent variable is and what the independent variable is. It's just those dummies. I'm going to include residual plots. You don't have to do that. Click OK. Yeah, we don't learn too much from the residual plots, except that it appears, oops, that we don't have homoscedastic errors exactly. That's fine. Whatever. What do we have here? Okay. Well, these coefficients are nice and smooth because this must be some fake data. But in any case, what we need to do is to develop an estimated regression equation, and these four numbers are the ones we're going to want. I'll write the estimated regression equation right here. So revenue is what we're actually estimating, not sales. And what does that look like? Well, our estimated revenue, or predicted revenue, is going to be beta B0, which is 70, plus 10 times the quarter one dummy. That means that there's a 10-point bonus for quarter one, not quarter 10, quarter one. Plus 105 times quarter two, plus 245 times quarter three. And that's our estimated regression equation, which is the answer. Part of the answer to part B is this equation. What this is saying, actually, if you recall, is that we just have a mean of, this is equivalent to saying that y bar, given that quarter equals 4, that's going to be 70. Right? And then for quarter equals 1, that's when all the dummies are 0. That's why that turns out to be the case, right? Because all these dummies are 0. For quarter equals 1, well, it's going to be 80, because we have it's 70 plus 10. For quarter equals 2, it's going to be 70 plus 105. Uh, 70 plus 105 equals 175. And then for the third quarter, the average revenue was 70 plus 245, which is, what is that? That's 315. So using quarter dummies can help account for this, in that it will, give us our means. And that's what we should get if we plug these in. So it asked us to make some forecasts. Let's make some forecasts. Wrap this. There we go. Okay, so what is our forecast? Well, we just have the quarter dummies and the intercept. So this is going to be the intercept, which is 70. Press an F4 to make this absolute, plus our quarter one coefficient times our quarter one dummy, plus our quarter two coefficient, F4 again, times my quarter two dummy, plus my quarter three coefficient, F4 again to make it absolute, times my quarter three dummy. Now looking at this, what do I have? I should have my intercept, that's B17, plus my coefficient B18 times D2, that's this right here, that's good, plus the next coefficient B19 times E2, plus the next coefficient times F2. That's good. That will work. You can just plug in these numbers, 70, 10, 105, and 245. But if they get large, you're going to have rounding errors. Also, as complicated as this is to read, you know where everything comes from, so you can track it back. So once you get in the habit of reading these formulas, they still are a little messy, but if you make a mistake, you at least can copy and paste this into Notepad or something, and then look at your formula to see what mistake you've made. If you just hard code it, meaning you just type the numbers in directly, you may forget where those numbers came from. And if you can comment, or feel the need to comment, that can be useful. But for our purposes, just having it in a formula it works pretty well. One of the important things here is just to make sure that we have our dollar signs all here, because if we didn't have our dollar signs, then when I copied and pasted it, what would happen is it would shift. Its reference to these would become a reference to these, which over time would become a reference to like this, and that doesn't mean anything. There's no numbers in there. It's going to just give you an error. if you don't include that. So we include those. And now I'm just copying and pasting these down. And you can see that I did my math correctly. Yes. So quarter 1 is 80, 175, 315, and 70. And you can see in our data 80, 175, 315, and 70. 80, 175, 315, and 70. Now one of the things it asked us to do is to predict the future, right? So let's make the future here, which is year 6, quarters 1, 2, 3, and 4. And we can just copy these over here. And so once we copy these all the way down, we can predict the future. That's what we think will happen. As you can see, when you just base your forecast on quarters, it just stays pretty fixed. All right, now I want to show you these on a graph. In order to show you these on a graph, that's the end of part B, actually. So we've computed estimates of quarterly data for year 6, quarterly sales for year 6. But I want to show you these on a graph. So in order to do that, it's actually easiest if I define my periods now. This is going to be 1, and then I'm going to add 1 every time. So we have 20 there, and this is going to be 21, 22, 23, 24. Now, if I take revenue, which is what I observed, and my forecasts based on quarters, then I can insert a scatter chart, and you can see what's going on here. I'm going to move this to a bigger chart so we can take a look. And you can see what happens. Okay, so blue is the real revenue, and then red is our forecast based on quarters. And what we're doing with the forecast based on quarters, it looks kind of like a heart chart or something like that, where we just have data that's just going up and down and skipping like that, right? I'm not sure why there's it's just not connecting those two because they're separated in the data set. But that's okay. So what happens then? Pardon me again. It's early for me. I need to finish my coffee. What happens then is that we have a stationary, no trend, right? We have a horizontal pattern in these forecasts, which means that in the beginning, if there is a trend, if there's an upward trend in the beginning, our forecasts are overshooting. And at the end, as you can see, our forecasts are undershooting, and that's not good. So in order to solve that problem, what we can do is we can introduce a trend variable, try to account for that trend. So let's do that. That's what it asks us to do in part C, correct? Yeah, so we define our periods and then use these dummy variables to develop an estimated regression equation. What is this model? Because we're going to have a new model now. So the new improved model, we noticed by inspection that we were missing a trend. So what do we want to do? Well, we're going to create a new model. And again, let's fix this. Why is revenue not sales? Our new model, model 2, is that revenue is equal to beta 0 plus beta 1 times quarter 1 plus beta 2 times quarter 2 plus beta 3 times quarter 3 dummy plus beta 4 times period plus epsilon. And that's our new model, and that's going to give us a new estimated regression equation. Est reg EQ means estimated regression equation. I already wrote it out here. So this means, or what we're going to estimate, actually, what we're going to produce is this. Revenue hat equals B0 plus B1 times QTR1 plus B2 times QTR2 plus B3 times QTR3 plus B4 times period. And if you look at period, this is what we're going to develop, except we're actually going to ask the computer again to find these numbers. All of these and this one. By adding period, what we've done is we've introduced a variable that just goes up steadily, which means that it's just going to give us a line, right? It's going to give us a straight line that goes, and essentially when we didn't have that in there, we were constricting beta 4 down here to be 0. That's one way to think of this, right? We were using this model already, but we said beta 4 has to equal 0. There's no period, there's no trend, right? That's what was in this model. Now we're saying, well, let's let beta 4 adjust. not force it to be 0. We can test to see if it's 0 or not, although we haven't talked much about how to correct for standard error problems, so we're probably not going to test to see if it's 0. But for the purposes of prediction, what we really just want is a point estimate. So we're going to have to introduce another x here. This is going to be period, and Excel requires that you keep these all together in a nice little rectangle. So I'm just going to take it from here, and then we'll estimate this. So again, data analysis, regression, click OK. Our y's have moved over because I introduced that new thing. So our revenue is our y again. Our x's are now going to be E through H. We still have labels. Revenue was quarter dums, now it's quarter dums and trend. Yeah, that's a trend variable. The period is the trend variable. Don't actually need residual plots. We're not going to use them really. Okay, now this is estimated. It has successfully estimated it. One thing you can say if you want to compare these is that the adjusted R squared is a lot better. Here it was adjusted R squared of 0.598. Here we have an adjusted R squared of 0.949. Again, this is fake data, so it's not surprising that you have such a good fit. It's capturing, I mean, I'm sure that they generated this data by pumping in something like this and then randomizing it artificially. Okay, so these are our estimated coefficients. We can write the estimated regression equation. This is what it will look like. Revenue hat again is the predicted or estimated value of revenue. It's going to be equal to negative 70.1 plus 45.025 times QTR1 plus 128.35 times QTR2 plus 256.675 times QTR3 plus 11.675 times period. Right, yeah, that's right. Okay. And now, if you want to find the predicted revenue for any period, you just need to plug in which quarter it is, right? 1 if it's 1, if it's quarter. QTR1 should be 1 if the quarter is 1. QTR2 should be 1 if the quarter is 2. QTR3 should be 1 if the quarter is 3, and they should all be 0 if it's quarter 4. And then you plug in what period it is, and that period will allow us to create kind of a linear trend. Not kind of a linear trend, exactly a linear trend. Okay, now it wants us to make a forecast. Okay, so we have forecasts based on quarters and trend. It's going to look a lot like what we did before, right? We still have the intercept, which is B17, and then we have our quarter 1 coefficient times our quarter 1 dummy plus our quarter 2 coefficient times our quarter 2 dummy plus our quarter 3 coefficient, F4 again, keeping these all absolute, times our quarter 3 dummy, oops, there we go, plus our period coefficient, 11.675, times our period variable. Wait, when we hit, oh, I forgot to make this one absolute. Hit enter. We can take a look at this just real quick. Yep, we can see our intercept here, and then these are our coefficients, and these are our data. And when we do this, we should get something that looks right. Oh, that's well, these are our forecasts. We copy and paste this down here. This should give us our variables. Okay, those are our projections based on our forecasts based on this data. What does this look like? Well, let's take a look. So we have period. And we have forecasts based on quarters and trend, and we have actual revenue. So insert, scatter, zigzaggy straight lines. I'm going to move this to new sheet. We don't actually want period on this graph. But this is, you can see that it's actually a pretty decent fit. Clearly, you know, we had negative revenue here, or negative forecasts. Well, that can happen. You can have losses. But compared to our chart with our quarter forecasts, where let's see if we can. Are these the same? Hold on one sec. The colors have changed. Our revenue should be blue. Let's make the revenue. Format data series, line color, solid line, blue. Okay. So now our revenue is still blue. Before, you can see the red predictions were off. Now it looks like our red predictions are much better. We no longer have that problem where we were overshooting at the beginning and then undershooting at the end. The trend, introducing the trend, has solved that a lot. So that's good. That's good. And our forecasts for the next year are probably going to be pretty. These lines should be connected, but our forecasts for the next year are probably going to be pretty solid because they're incorporating that trend. It looks like we have a little bit of a problem where we've maybe underestimated here or overshot here and then undershot here. Now we're undershooting here and overshooting here. So there might be some increasing noise in the revenue, right? The revenue might be bouncing around more as time goes on, which might indicate that when we would deseasonalize this data, what we would really want to do is use a multiplicative model. If for the quarters, it might be that the quarters are representing a percentage. And as it goes forward, you might want to, as the years continue and revenue grows, you might expect to see a higher and higher percentage deviation there. Using the quarters and trend model, all that we've done really, and it can be kind of hard to see this with the change series chart type. Yeah, this is what I want to do. What we've really done is we've said, okay, well, we're going to allow there to be a slope, but that slope's going to be the same for each quarter. And for this quarter, which is quarter 3, I believe, we now have an intercept that's here, but this is our slope. For this quarter, we have an intercept that's here, but this is our slope. For this quarter, we have an intercept that's here, but this is our slope. And for this quarter, we have an intercept down here, but this is our slope. So the slope is the same in each case. When you do a regression with a linear regression with quarter, dummies, and trend, you have constant slope unless you introduce some kind of interaction term. But you've allowed the intercepts to adjust so that instead of just estimating one line, you're estimating essentially four lines that are restrained to have the same slope. Or constrained. Okay, so that's how you solve this problem. Do we create our forecasts? It asks us to do that. We did that implicitly, right? It's as easy as copying and pasting the predictive or the estimated regression equation formula into here. As long as you have your quarter data here, and your period data in there, then you're in good shape, right? It'll automatically project it. And you can see that these projections are much different from the ones that we had with the other ones, with the dummies only, because those dummies only were not incorporating the trend. So there you go. That's how you solve this problem. We use dummy variables and regression techniques, as well as the trend variable, to make some forecasts and projections. If you have any questions, as always, shoot me an email at jjdelaney@ualr.edu, or you can leave me a comment on YouTube, and I'll be in touch soon. Thanks, guys. Bye.